Okay, today we'll be talking about reflections, and there's just two quick definitions for this one. You're just going to have any old type of line will be your reflection, and your reflection will just be across it. So a simple diagram, we'll draw it out real fast. Okay, now this is just a drawing, and it's not going to be the best in the world, but you just got to understand it's just going to work. Uh, the reflection is just going to be a reflection across it. Now, a way to tell the reflection is that the distances from each point to the reflection line will be equal distance. So these two will be congruent, okay? And then these two distances will be congruent as well. But they're going to be different congruencies unless you have a straight up and down line that you're just reflecting across, okay? All right, and if you check all three of the points, especially when you're dealing with a triangle, you should have it be all the same distance. And as you can see, we can already see discrepancy with this one. But let's just say that it was. Okay? All right, so we're going to go take a look at Desmos to just see how the reflections work and just talk about their changes and stuff, okay? Okay, so let's say that we had the 3 points, or let's go ahead and draw another one. Let's go ahead and do crazy stuff like a quadrilateral. So let's say 2 comma 3. There we go. Okay, so let's say we're dealing with this quadrilateral right here, and we want a reflection. Now, typically it depends upon where your reflection is. So x equals, whoops, caps lock. X equals, let's say, -1. Okay, so if we wanted a reflection across this, we would want to make sure that the points are equidistant. So if you notice this first point right here, 1, 2, is 2 units from the line. So over here at -3, 2, we would have the other point. So -3, 2. Okay, and then we would do the same thing here with this 3, 2. It is 1, 2, 3, 4 units from there, so this one has to be 4 units from here. So 4 from that would be -5, 2. Okay, all right, and then we do the same thing for the others, and it should be, what was that, 2? So that's a distance of 3. So that would be a -4, 3. Okay, and then comma, let me see, what was that, 4? So it's 5. So that is, and when you're mapping this out, make sure you check with Desmos too, just to make sure that everything's working out exactly as is. Okay? All right. Now, if I change it, if I change the reflection, let's say we change it to something else, obviously these points are going to all change. Okay? All right. Now, if I change this to a y equals, obviously I'm going to change the distances on those. So let's make that a y equals 1 type of line. Okay, so now what's going to happen is I'm not going to have these same points because obviously that would be a reflection that's off. Okay, but I'm going to change everything so that the points are now reflecting across the y equals 1 line. So once again, I'm going to look for the same distance between the points in a line. So I'm going to be looking at, let me see, 1, 0. Okay, and then I'm going to go comma, what is that, 3, 0. Okay, and I'm going to have comma, what is that, 2, -1. Okay, and then that is 4, -1. Okay, and as you can see, the reflection looks pretty darn good across there. All right. All right. Now there are some techniques to working with this stuff. You will, if you're reflecting across a y equals line, you will keep the same x-axis or the same x points or the same x coordinates. Okay, whereas if you were reflecting across the x line, let's go back to this, let's make that -1. Okay, you will keep the same y points, the y coordinates, but you will actually switch the x coordinates. Okay, they will be changing across there. All right. Now, there's some different stuff that you can do. You can have some different reflections. Some important reflections for you guys to know later on, and just to talk about where this stuff is going, and I'm going to talk about algebra, is if you were to actually have an equation, y equals 3x minus 2, okay, and what you could do is, this is something you'll learn about inverses. There's an important line called the y equals x line. Okay, now why is that important? Because if we find the inverse of this function right here, okay, this symmetry will make this look really nice. Now here's the cool thing. If we wanted the inverse function of this, like if you remember inverse functions, the inverse of add is minus, the inverse of minus is add, all that stuff. So the inverse of this would be 1/3 x plus 2. X plus 2. Okay, and we'll put this in parentheses. And you'll learn techniques for this later, okay? But here's the cool thing, is that when I actually do this and I check it out with the y equals x line, they will actually not only cross at the same point on the y equals x line, but they'll also be a perfect, if you tilt your head about 45 degrees to the right, they'll make a perfectly symmetrical shape. And this is the reflection across it. So this is actually a really good application of where you use reflections in algebra. Okay, and if they make this nice reflection, you can always test out to see if two functions are inverse of each other, because they'll make this really beautiful reflection. Okay, all right, that's it for reflections in geometry. I'll talk to you later.